Also, PFBA highly extracted with water in soil with PFAS. And also, it is main components found in rainwater, which human will intake it because rainwater is our main source of drinking water. For the blue highlight one, it is short to medium chain PFAS compound, this three. This three is relatively higher water solubility, which can mainly detected in air particle because it will stick to water, more likely to be detected in water sample. Also, it is a breakdown from larger PFAS that will use in manufacture. Because of its property of water solubility, it will leak to environmental water easily, causing more contents in water sample. As you can see, it's relatively higher. As a comparison, you can see this value is only 0. something. For the long chain one compared with the short chain one, because it has lower water solubility, it will stick to the sediment more, like organic matter more, and also this long chain PFAS compound is less widely produced or released, so it had less content in the water sample. That's the potential reason of, I think, causing the low recovery rate. First, for the blue highlight PFAS compound is more hydrophobic and is not likely to dissolve in water sample, so it has very low recovery rate. And for this pink one, the pink arrow pointing that one, it is a water sample which causing the matrix effect. This will interfere measurement and make it hard to detect for this PFAS element. So maybe also because it has very low concentration in that water sample, or some sample loss and human error may make to cause this low recovery rate. Next, I'm going to talk about the Minister of Environment Japan that method. We have to make 1 liter for each sample. So by comparing sulfonics and carboxylates, the concentration of sulfonics is relatively higher. As you can see, comparing. So, because PFBA is the major components found in rainwater, so its concentration in blue highlight is the highest. Here are the photo of us doing the suction, filtration, and we are preparing a sample by pouring acetic acid, and the sample is done here. So here are the potential reasons that I think causing the low recovery rate. First, the concentration is quite diluted because it's 1 liter, right? So it may be below the detection range, so we can't detect it, causing low recovery rate. And also, we may lose some of the short chain PFAS compounds during the process. And for the solid phase extraction, this process, it has an optimal sample volume. Maybe 1 liter is too much for this experiment, so it's causing a loss. So we move on to the soil part. For soil, it is quite different from water. For soil, the sulfonic compound is much less than carboxylate, because sulfonic PFAS is bind with soil organic matter tightly. And with the pH interference, if it is in an acidic condition, the soil is positively charged, but the sulfonic is negatively charged. It will bond very tightly and causing less extractable from soil. As you can see there, it's almost blank for the sulfonics. Yeah, the potential reason for low recovery rate. First, it's mainly because of strong bond with soil organic carbon. As I said in the previous slides, the sulfonic is mainly bond with soil matter, and carboxylic is bind with water more. And also for the intermediate degradation product, it may already transform during the experiment. And also standard extraction process, like the experimental procedure we have done, may not release those compounds from soil. Let's move on to the solvent and water part. For concentration of PFAS in water, like I said, is much more in water than solvent. Since PFAS at air-water interface is 2 to 16 times higher than at the non-aqueous phases, and short-chain PFAS compound is more mobile in water. However, long-chain bind to soil more, like I previously mentioned. And I think that it may be because the solvent extraction is incomplete. The solvent can't penetrate all soil and causing lower PFAS content in solvent. Here are the potential reasons that causing the low recovery rate. First, you can see here, the whole column here is red color, which is unsatisfying. I mean, for this abnormal data, again, it's only my human error, because compared with other data used and made, they don't have this problem. And also, short chain PFAS easier to get lost, whereas long chain bind tightly with soil. So maybe some sample loss and incomplete extraction process. So from the experimental results, we can see that water can uptake more PFAS than solvent. So let's move on to the vegetable part, spinach. For this, PFOS, PFHXS, and PFNA, these three compounds not even detected, same as the previous experimental result in the article. So maybe I think that maybe the concentration is too low to uptake, or is there any other reason? For PFBA, it has the highest concentration. And by calculating using the sample 1, we can know that the percentage of total PFAS in sample 1 is 54.6%. For PFOA, is within the range 0.1 to 14.3% in the research article. So these are the compounds that mentioned in the article, so I take this one out to talk about it. Actually, only for spinach, new method doesn't really work well, because you can see for the old method is more within the range, and for the new one it's out of the range already. Also for that graph also, I think the potential reason is that reduction of the solvent may make the solvent can't keep PFAS in sample, and may have some sample loss, especially for long chain PFAS. And maybe because we already strike a balance for the old method, so maybe new method doesn't really fit on it, and it will disturb the balance. For tomato, we have short chain PFAS accumulate more in tomato. Mostly it's PFBA, PFBA, and PFHXA. These are water soluble compounds, as I said before, but for the long chain one is not even detected. Since we have done both old and new method, and the new method is win in the tomato part. So I think because it get a better recovery rate, you can see that there's less red marks there, which means that red is unsatisfying, right? So here is mostly red for this one, and only a few red for that one. So as mostly red here is the short chain PFAS, which are more polar and more easily affected by the solvent interaction. Also, new method lessen the matrix effect. This caused the ion suppression and enhancement, which is not satisfying also. By comparing with other vegetable experimental results, tomato exhibit the best recovery rate. As you can see, it's like near 1 ideal and within the range. By using the new method, it's milliliter, 4 milliliter, 4 milliliter method. Yeah. For cucumber, it has quite different uptake efficiency because you can see that less PFAS is uptake compared with other vegetable. And for short chain PFAS, it's accumulating more in cucumber. For the long chain shown here, because it's more hydrophobic, like I mentioned, it is less mobile in plant tissue, but bind more in the root. So you can see it's like also blank. For this one, it has some abnormal recovery rate. So I guess the reason of having it is for the FOSA compound is tend to lose in extraction process. So maybe it's the reason of like quite abnormal recovery rate. And for this one, extremely high recovery rate, maybe I found that exit can actually improve the PFAS availability. Maybe I accidentally add too much acid. It's just like guessing. By comparing with like new and old method, we can see that these are really out of the range, but that one is like more closer. So yeah, it is like closer to one is really ideal. So new method suits cucumber sample. So here is the summary. So the main reason of less PFAS absorption in soil to plants is because of the organic carbon content. Since long chain bind with soil with high organic carbon content, it's difficult to dissolve in water, causing the limitation in transferring long chain PFAS into the plant tissue. That really stated in Dr. Ng article, so I call it here to give up my summary. And then here are the water and solvent graph. As you can see that with the water, it has more PFAS content, so water uptake more PFAS. That's the end of my presentation, and really thank you for the whole 2 months caring and for all your kindness and teaching. Yeah, thank you.